Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today we are going to discuss a very interesting LeetCode problem, LeetCode 2340, minimum adjacent swaps to make a valid array. This is a very important question because it has been asked by Amazon and Meta in their last 1 month of interviews, so it's kind of critical. Now what does this question say? So you have been given a zero indexed array as shown in this example here, and you have to convert to a valid array by using minimum number of swaps. Now, what do we define by a valid array? So, in a valid array, the largest element of the array should occur in the rightmost position, and the smallest element in the array should occur in the leftmost position. Though the largest element or smallest element could be in duplicates, they could be occurring more than once, but you should have the largest one here and the smallest one here in the leftmost side, that too with minimum number of swaps. So basically, you need to bring the array in valid array format with minimum number of swaps you make. Okay, so let's look at this example here. So in example 1 talks about this array. As you can see, 3 has occurred twice there, but it's not the smallest one. 1 is the smallest one and 5 is the largest one, which also has occurred twice now. So how will you make sure that you're doing minimum number of swaps while getting the valid array format? You will try to find the largest element of the array close to the rightmost index, and you will try to find the smallest integer or smallest value in the array closest to the leftmost index, even though you might have more than one occurrences as shown in this example. But to ensure that you are doing minimum number of swaps, you will try to grab the largest one which is closer to the rightmost index, and you will similarly try to grab the smallest element which is closer to the leftmost side. So that is one thing which you need to remember. Also, there could be an exception. Exception could be when your smallest element is on the righter side of the array, whereas your largest element occurs in the leftmost side of the array. In that case, when you are doing the swaps, your largest element will cross your smallest element, because you will bring your smallest element with swaps to your leftmost index, and you will bring your largest element to your rightmost index. So they will of course collide, and whenever they collide, at that time you are doing one swap instead of two swap. So in that case, your minimum number of swap will be one less than usual. So I'll explain that when we are doing the question, but let me walk you through this example now. So for example, this is the array given to you, 3, 4, 5, 5, 3, 1. In that case, first I need to bring my largest element to rightmost side. So how can I bring there? First of all, I'll have to find it, right? So suppose I find more than one occurrences of 5, which are this, index 2 and index 3. Now I check which index is closest to the rightmost index. So index 3 is the closest one, so I'll swap 5 and 3. And then 3 comes here and 5 comes here, then I'll swap 5 and 1, and my 5 comes on the right side in 2 swaps. Now I'll move my 1, which is the smallest one, so I'll first find the smallest one, which I see it's here. Then I'll move it going forward to this index, swap it with this index, then this index, and finally this index. So in all, you are incurring 6 swaps to reach that valid array form. Okay. Now let's look at another example. For example, this is an array given to you which has only one element, 9. In this scenario, there are 0 swaps required because your array is already in the valid form. There is no smallest or largest here because it's just one element in the array. So I hope you understand the question now. Let's start coding it, and that will explain how do we handle the edge case, how do we find the largest element's occurrence, which is closest to the rightmost index, vis-a-vis how do we find the smallest element's occurrence, which is close to the leftmost index. So all that thing I will explain during the coding stage of it. I would propose you code it alongside me so that you can understand the nitty-gritties of the question with me. If you have any doubts, ask them in the comments here. I'll be happy to address it. So let's begin the coding. So first of all, I will initialize a few of my variables. I'm basically initializing my largest element, smallest element, largest element's index, and smallest element's index. And how do I initialize it? My largest element I can initialize as minus math.infinity. Smallest element math.infinity. Largest index 0 and smallest index 0, because I'm starting from the leftmost side to find these. Okay. After that, I will run a for loop for I, n in nums, and then I check and find which is the smallest element, which is the largest element. Right now, I have initialized my smallest as maths.infinity. So if variable, that is the index I variable name, index I value is less than smallest, in that case, I will update my smallest value to n and my smallest index value to I, because ith index value is n, right? Replicate the same code here for largest, because I've initialized largest with minus math.infinity. So if any integer value is greater than largest, in that case I'll update my largest value to n. But mind you, we also need to check if there are more than one occurrences of the largest value or more than one occurrences of the smallest value. And then we need to take that value which is closest to the leftmost index for smallest and which is close to the rightmost index for the largest. So to do that, let's review our code again. So if I'm looping from left to right in the array, in this case, even if my smallest value occurs again, I'm still taking n less than smallest. So it will be equal, which is already met here. So my smallest occurrence which has occurred for the first time close to the leftmost index when I'm looping from left to right, that still stays the same. Smallest index still stays the same because there is no equal to here. So even if the same value has occurred again, still this value smallest index will not get updated and you will have the index closest to the leftmost side. So in this, no code change is required. Now for this one, for the largest one, you are still looping from left to right and you might get something closer to the rightmost index, but your value is already updated from somewhere close to the leftmost index, right? But you want to update it. So to do that, I will put an equal to here. In that ways, even if it comes across another 5, it will update the largest index with this new index. That ways you will have a value closer to the rightmost index. So I hope you understand how I handled multiple occurrences of smallest in value or largest value, and how I'm taking value closest to leftmost index for smallest and closest to rightmost index for largest. So once you do it using an example, you will understand it better. Let's move ahead. So let me update my total length. N is equal to length of num minus 1, because in Python, the length of array is length of nums minus 1. It's non-inclusive. So what should be my result? The minimum number of swaps which are needed are number of swaps which are needed to move from the smallest index value. Like if the smallest index value is say 2. So if from the smallest index value to 0, which is equal to smallest index, right? And the number of swaps required for this one to move from here to here is not largest index. It's actually length of the array minus largest index. Because your largest index defines the length from here, and you have to do swaps from here to here. So that's why the total number of swaps would be the smallest index to do the swaps with the leftmost index value, plus total length of the array, that is n, minus largest index, which would be the total number of swaps needed to go from largest value in the array to the rightmost index. So that's the total number of swaps you would need. But we haven't handled one edge case here actually, which is when your smallest value is towards the rightmost side, whereas your largest value is towards the leftmost side, and they would cross. When your smallest value is on the right side of the array, whereas your largest value on the left side of the array. In that case, your smallest value and largest value will swap at some point, then they will come across each other and swap, due to which you will have one less swap needed, as you will be doing one swap and moving them both together. So in that case, my return result would be result minus 1, because there is one less swap required if the smallest index is greater than your largest index, and you return result. So let's run it. So it's accepted. Let's see. Yeah, so as you can see, our code is doing really well here. So let me just repeat this code for you so that you can understand it better. If you have any doubts, ask them anytime. So I first initialize my 4 variables, which is my largest element in the array, my smallest element in the array, my largest index, and my smallest index. My largest element I initialize by minus infinity, smallest by plus infinity, and both the indices as 0 because I'm looping from left to right. Now I loop through the entire array nums and try to find my smallest value, smallest element, and my largest value so that I can have the indices. But before doing that, I have to recognize that the largest or smallest value could have occurred more than once. In such a scenario, I need the index for that occurrence for the smallest, which is closest to the leftmost index, because I need minimum swaps. And I need the index for the largest element closer to the rightmost index because I need the minimum swaps. For the smallest index, it's easier, right? Because you are taking if n is less than smallest. So even if there is a repetition which occurs later on, you are not updating the index essentially because there is no n less than equal to. But you need it to update if it is largest because you want the rightmost occurrence. So for doing that, I have put if n is greater than equal to. So even if it comes across the largest element again, then it updates the largest index. So that's your part of code when you find that leftmost occurrence of smallest and rightmost occurrence of largest to do the swaps. Now, once you realize you have the smallest index and largest index, now you want to count the total number of swaps required. To do that, for the smallest index, you have to go to the leftmost index, that is the 0th index from the smallest index. So the number of swaps required is actually the smallest index. So that's easier part. For largest index, number of swaps required is going from largest index to the rightmost index. To do that, you need to count total number of indices, which is n, length of nums minus 1, and minus largest index. That's what I'm doing here. Now we just need to handle one edge case where your smallest index is actually greater than your largest index. That is, your smallest number has occurred after your largest number. In that case, they would swap together at one instance when they're crossing each other. So you would need one less swap for them. And that's what I've done here. Return result minus 1 if your smallest index is greater than largest index, else return result. So I hope you understand the question now. If you like my way of solving problems, subscribe to my channel because I post a video every day and it would keep you notified for my latest videos. So I hope you liked the session today. Let's stay connected. Thank you.